Hello all. Let us discuss about the circle. This is one of the conic section. So what do you remember about the circle? The circle means there will be a center point and there will be a constant distance from this center point. And all those points are at a constant distance. When you connect all those points, you'll get circle. Example: always draw the circle in xy coordinate. This is your circle. This is your center C, and this is P. So such points, if you connect all the points, then you'll get this constant distance, what we call it as a radius. So this is the definition of the circle. The circle is nothing but the locus of all the points which are at a distance, at a constant distance from a fixed point. Okay. So this circle, you'll have a standard equation of circle. What do you mean by standard? Standard means you'll have a center at 0 comma 0 and your radius will be r. So for this, how do you find the this equation of the circle? The reference is you are always take an arbitrary point p on the circle. From this, what do you know? If you draw this, x is nothing but what is that? This is your x distance and this is y distance. That means so now, yeah, either you can form a, so let us form a triangle, a perpendicular drawn here, and this point is nothing but this is your x comma 0, right? Y coordinate 0. This is y axis, this is x axis. So x comma 0. So this forms a right angle triangle. So that means what? A triangle C, this is your D, CPD is your right angle triangle, right angle to triangle. So in a right angle triangle, you can apply Pythagoras theorem, which is nothing but CP square. This is your hypotenuse equal to CD square plus DP square equal to CP. What is the CP? R square. CD is nothing but this distance 0 comma 0. This is x comma 0. That means what? This distance is x and this distance is y. This is x square plus y square. So this equation, what we call it as a standard equation. We have another equation which is called general equation. General equation of circle, not exactly, but you have given center not 0 comma 0 but h comma k. This h comma k, how do you do that? That is again you have x comma y. You have center not from in the center but somewhere h distance from y axis. This is y axis, this is x axis. So this is h distance and you have a distance k and your point somewhere here which is p of x comma y. If you connect these 2 points, this is a radius. So now how do you get this your triangle? Again draw a perpendicular to the horizontal diameter, that is a radius. You'll get a d point here and see your c. What is c? H comma k and px1. So what is this point? This point is nothing but this is x, means if you draw parallel to the y axis, this distance, this is nothing but this distance x. Okay, this distance you have y, this is k and this is y. So now what do you want? You want this distance. This distance is nothing but x minus this is x and this is h. So these two when you subtract, this is x, okay, and this, okay. If you subtract x minus h, you'll get this one, x minus h. This is y minus k. So as usual, again triangle. What is the triangle? Triangle CPD. R square is equal to your horizontal distance x minus h whole square plus y minus k whole square. So now a little bit difficult. So if you have always we won't be given, we won't be given with the center. So in that case, we need some more sophisticated equation where from where we can arrive the center and the radius. So let's what we'll do, rewrite the equation h minus x minus h whole square plus y minus k whole square is equal to r square. Let us expand this. X square minus 2hx plus h square plus y square minus 2ky plus k square is equal to r square. So we'll keep everything here. X square um, minus 2hx plus y square minus 2ky. What I'm doing is I'm taking every constant on one side. H square, k square, r square, everything will be constant. So that is why I'm keeping h square plus k square minus r square is equal to 0. So what I'm doing now, I'm taking 2g equal to minus 2h and 2f is equal to minus 2k, and taking these things, these are all the three constants as c. So in that case, what I'll get it, x square plus 2gx plus y square plus 2fy plus c equal to 0. So this is somewhat simplified equation from that. And then now I am doing another modification. So what I am doing is add and subtract g square and f square. So modified equation becomes x square plus 2gx plus g square, and then I am y square 2fy plus f square. Now I have used all the four. Now here I have added g square and added f square. Now I'm subtracting. So I'll keep c and then subtract um, g square minus f square equal to 0. So if we keep these items on the left side and bring it to right hand side, you will have x square plus 2gx plus g square plus y square plus 2fy plus f square is equal to g square plus f square minus c. So I will simplify these equations, this part and this part. How can I simplify? This is nothing but x plus g whole square, and this one y plus f whole square. This is equal to g square plus f square minus c. So this equation I can rewrite x minus g whole square, and this also I can write y minus of f whole square. This side, instead of writing like that, I am making a root g square plus f square minus c and then taking the square root. This is very much similar to the, so let us compare. So compare this equation with the standard or a modified standard, like nothing but x minus h whole square plus y minus k whole square is equal to r square. On comparison this, you'll have this where your h is the, this is your h, this is your k. H and k are centers. So now the center becomes minus g minus f. What is your radius? Radius is nothing but whatever there in the square side. This r square is equal to this part. Then your r is nothing but root of g square plus f square minus. So this is the required equation. Okay, so your equation final, like the final equation, which looks like this. if you had to bring your equation like this, so that these are the two parameters, you will get it. Okay, so if you have something like this equation, sorry, this is your standard equation. If you have something like this, you have x square 2gx y square plus 2fy plus c, then your center becomes minus g minus f, and r is equal to g square plus f square minus c. So in mathematics, whenever you see a equation, you'll have food for your mind. That means you need to think. For example, here r is equal to root of g square f square minus c. I'll take the term g square plus f square minus c. Suppose this is greater than 0. That means what? You have a real circle, right? Real circle. You have the radius, right? Or else, if you have g square plus f square minus c equal to 0, then what is that? You don't have radius. That means what? You are getting your circle becomes point, right? Only one point. No radius, no constant distance. That means what? You have only one point. Say suppose you have g square plus f square minus c less than 0. That means what? Negative. So negative root gives a complex number. Complex number you will study in the upcoming lecture. Complex number, that is what, that means there is no locus. There is an imaginary circle. Imaginary circle. So these are the insights that you will get from this expression. Theorem in circle, which states that the circle passing through the points of intersection of the line lx plus my plus n equal to 0, and the circle x square plus y square plus 2gx plus 2fy plus c equal to 0 is the circle of the form. So if you have intersection of line and the circle, this circle, so you can have a form of circle like this. So how is it possible? So the circle will be something like this. You have center h comma k, and there is a line. This line is lx plus my plus n equal to 0. So h comma k, this will be equal to, this circle equation will be x square plus y square plus 2gx plus 2fy plus c equal to 0. So if two elements are there, circle and the circle and the line, suppose this line intersects this circle at two intersection points, then the equation of this circle can be represented as this circle, we can call it as S. This circle they are called as L. Okay, so we can represent S plus lambda L equal to 0. So S already 0, L all 0. So if you add multiple of L with S, it becomes 0. So how do you write? X square plus y square plus 2gx plus 2fy plus c plus lambda times lx my plus n. This is equal to 0. If you multiply together and get the x term, x square plus y square, and take x as a common, 2g you have the here lambda l plus y constant, y outside, and then you have 2f plus m, lambda m, plus lambda c plus lambda n equal to 0. So if you see what the properties of circle, properties of or characteristic, what are they? So coefficients of x square and y square should be 1, and there should not be any xy term. So no xy term, only x square y square. This is second order. X square, one should be there, and this is second order equation. So it is obeying these two conditions. Hence, even if you have you are combining the multiple of line, you have again the same circle which is having this form. So this is circle. That is what we have to understand. This is again a circle. This will be useful while doing the problem. We'll see the problem also. So here in this example, we have a circle. We have circle which is like this. This radius equal to, this is square means 4, okay, and you have radius. This is what your x square plus y square equal to 16, and you have another line which is 3x plus y plus 5 equal to 0. It can be represented as y is equal to minus 3x minus 5. That means y is equal to minus 3x minus slope is minus 3 and the intercept minus 5. Somewhere it is going beyond minus 5 is the intercept. Here it intercept, and then slope is minus slope. So something it cuts like this. Suppose, so what he is telling is, if we make this line as a diameter, okay, so what should be the circle equation? So as per our theorem, so theorem suggests, so equation s is equal to x square plus y square is equal to 16. That means what? X square plus y square minus 16 equal to 0. S is equal to, and L is equal to 3x plus y plus 5 equal to 0. And we have, as per theorem, lambda L equal to 0. That means x square y square minus 16 plus lambda into 3x plus y plus 5 equal to 0. So so take the x term, x square plus y square minus 16, will see that, and x plus x, you have lambda, 3 lambda, okay, and then 3 lambda and y lambda plus y lambda minus 16 plus 5 minus 11 equal to 0. So this is the equation we get. So compare this equation with the standard equation, which is nothing but x square plus y square plus 2gx plus 2fy plus z equal to 0. So here 2g equal to x coefficient equal to 3 lambda. That means g is equal to 3 by 2 lambda, and 2f is equal to y lambda, uh, lambda y. So lambda. So f is equal to lambda by 2. So as per the standard equation, your center will be minus g minus f, which is nothing but minus 3 by 2 lambda and lambda minus lambda by 2 lambda. So if you substitute, this is the intersection point. So this is the center. So center means you have the circle and your line is like this. Your this center is minus 3 by 2 lambda minus lambda by 2. So this point has to satisfy, because this is the line center and it passes through the line, okay. Then you substitute minus 3 by 2 lambda and minus half lambda in line equation. So line equation 3, what is the line equation? 3x plus y plus 5 equal to 0. Sorry. So substitute x and y. This is a point x comma y. So substitute here, you will get 3 into minus 3 by 2 lambda plus minus half lambda plus 5 equal to 0. Here becomes 9 by 2 lambda and then minus lambda by 2 plus 5 equal to 0. This becomes the same denominator, so minus 10 lambda by 2 plus 5 equal to 0. This is minus 5 lambda plus 5 equal to 0. That means lambda equal to 1. So if lambda equal to 1, you will get the equation. What is the equation? Now substitute lambda equal to 1 in this equation. Where is this equation? That becomes 3x x square plus y square, 3x plus y minus minus 11 equal to 0. This is your equation. Now again we have another theorem which states that the equation of the circle with points x1 y1 and x2 y2 as extremities of one of the diameter of the circle is. So our circle is like this, and we have the diameter, and let us mark this as a, this is b, and you have x1 and comma y1 here, and this is x2 comma y2. If you have any point here p, this is x comma y. Okay, when you connect this with this point and this point, it forms an angle of 90 degrees. There is a theorem called Thales theorem. The theorem is called Thales theorem, also known as angle in a semicircle theorem. The angle subtended by diameter of a circle. That means if you take a circle or a semicircle, which is this half, this diameter makes an angle of this any point on this circumference. If you take any point, connect the extreme point to that point and this point, this extreme point to that point, it forms 90 degrees angle. So that means what? The angle A P B equal to 90 degrees. Okay, that means what? See, this tells us we can make use of in analytical geometry m1 m2 equal to minus 1. That is, if you have two lines which are perpendicular to each other, their slopes, if you multiply their slopes, it will be equal to minus 1. Okay, so now our job is to find slope of AP and PB. So how do you find the slope? So slope is nothing but y minus, so common formula y2 minus y1 x2 minus x1. This is a general formula. So in this case A and P, if you take A as x1 y1 and this is x2 y2, then it becomes y minus, this is AP slope, y minus y1 divided by x minus x1. And PB slope, this is again I'll take this is the second point, this is the first point. That means what? Y minus y2 divided by x minus x2. Now, so as per the equation m1 m2 equal to minus 1, I'll take this as m1, this is m2. So y minus y1 divided by x minus x1 into x minus, that is y minus y2 divided by x minus x2 equal to minus 1. If you take the cross multiplication, you'll get y minus y1 into y minus y2 equal to minus of x minus x1, x minus x2. If you bring this side, it will be x minus x1, x minus x2 equal to, sorry, plus y minus y1 into y minus y2. This is the equation. So if you have a circle with extremities as x1 2 points, this is one point, this is another point, then your equation will be subtract from x, you subtract x1 and then multiply with x minus x2 plus y minus y1 into y minus y2 equal to 0. So to understand the theorem, to form an equation with the 2 points, we have an example given in the textbook. So we'll look into that. So what you people are telling, find the general equation of a circle whose diameter is line segment joining the 2 points. So circle given, circle given, and two extreme points. This is minus 4 comma minus 2, and this is 1 comma 1. So we know the formula. What is the formula for general equation? X minus x1, x minus x2 plus y minus y1 into y minus y2 equal to 0. So write down x minus, what is x1? This is minus minus 4, x minus minus 2 plus y minus, sorry, this is x1, 1, y minus y1, this is minus 2, y minus 1 1 equal to 0. That is x plus 4, x minus 1 plus y plus 2 into y minus 1 equal to 0. So what is this? X into x square, x into minus 1 minus x, 4 into x plus 4x minus 4, and then plus y into y square, y minus y plus 2y minus 2 equal to 0. So you have uh, x square minus 5x, this is plus 3x, and then y square, 2y minus y plus y, and you have minus 4 minus 2 minus 6 equal to 0. That is x square plus y square plus 3x plus y minus 6 equal to 0. So there is no xy term, you have x square and y square coefficient 1. So this is the equation of the circle. We have one more theorem. The position of the point P, this is a point P, x where point has a x1 y1 as coordinate with respect to a given circle. This is general equation, x square plus y square plus 2x2fy plus c equal to 0 in the plane containing the circle is outside or on or inside the circle according as x1 square plus y1 square plus 2gx1 plus 2fm plus c equal to 0 greater than 0 or okay. So first of all, what we'll do, so the here we'll check whether it is, if it is, if you substitute p of x1 y1 in general equation. Okay, so how do you substitute? So you need to, you okay, not that one, we'll see that. Okay, find cp. So cp, how do you find? Distance formula. And again find cq. What is cq? It is radius of the circle. So how do you find radius? For the general equation, radius equal to root of g square plus f square minus c. So this you can find out, and then This is nothing but it's CQ. Okay, you have CQ and CP. If CP modulus of, that is the distance, if CP is greater than CQ, then it is outside the circle. The point is outside the circle. Suppose equal to 0, equal to CQ, sorry, this is on the circle. Suppose it is less than CQ, that is inside the circle. Okay, this is one inference that will get it. Instead of CP, you can compare with the CP square also. It's nothing but R square, which is nothing but a root, sorry, not root 2, we take the root out. Uh, you'll have G square plus F square plus C, minus C. This you can find out. Similar way, CQ square, which is nothing but what sorry, CP square is nothing but the distance, root of distance. This is nothing but square of distance. So this is radius square. So if CP square is greater than R square, then it is outside circle. Equal to R square, on the circle, and less than R square, this is again inside circle. This is another way of comparing. And the next thing is you substitute. This is now only you have to substitute. This is the third way of checking whether the point is inside or outside. This is what initially I told. So substitute P of x1 y1 in general equation. That is x1 square plus y1 square plus 2gx1 plus 2f y1 plus c. If it is greater than 0, outside circle, equal to 0, on the circle, and less than 0, inside the circle. So now we have an example here. In this example, the position of the point 2, 3 with respect to the circle. So we don't want to draw the curve. We'll directly will get substitute in the equation, which is nothing but this equation for p x1 y1. The equation is x1 square plus y1 square plus 2gx1 plus 2f y1 plus c equal to we have to find out what is this value. What is the value here? X1 is this is x1, this is x2, x1 y1. We can directly substitute, which is 2 square plus 3 square minus 6 to 2 minus 8 into 3 plus 12. This is 4 plus 6 minus 12, sorry, plus 9 minus 8 3 is 24 plus 12. This becomes 11 minus 36 what plus 12. 11 minus 24, which is minus 11 less than 0. That means what? It is inside the circle. Now we'll find the equation of tangent and normal at a point P on a given circle. So P is the point on the circle, and there is a tangent if you are trying to draw a tangent. So the process will have 2 points, P of x1 y1 and Q of x2 y2. This is a chord. So what we are doing, we'll substitute those points on the circle and we'll find out the let P of x1 y1 and Q of x2 y2 be 2 points on the circle. Which circle? General circle. X square plus y square 2gx plus 2fy plus c equal to 0. If you substitute that, we'll get two equations. First equation will be x1 square for p of x1 y1 substitution. We'll get x1 square plus y1 square plus 2gx1 plus 2f y1 plus c equal to 0. This is the first equation. The second equation for q of x2 and y2, this will be x2 square y2 square plus 2gx2 plus 2f y2 plus c equal to 0. So this is the second equation. So you have two equations. So what we are doing is from 2 subtract 1. This is subtraction process. For every action there is a reason. So if you subtract that, how do you get it? You will get this is a process. Okay, what is the process? If you have the tangent will have only one point. Making a chord into tangent, the process is bringing q to the p, so that x1 it becomes equal to x2. So now we have two equations. This is reality, and then start bringing the q to the p. So what we are doing, then we are subtraction. This is the main important point. We are subtracting equation 1 from 2. So in that process it will be x2 square minus x1 square plus y2 square minus y1 square, and then you have common 2g, which is x2 minus x1 plus common 2f, which is y2 minus y1, where c cancel, c minus c, let us write this is equal to 0. So let us write so you have x2 minus x1 here, there will be x2 minus x1 in this equation. So let us write briefly so that you will understand. So x2 minus x1, x2 plus x1, this is the resultant. So this part becomes like this. So this part becomes this one, this part. Now this part y2 minus y1 into y2 plus y1. So this portion becomes, and this is yours. Now we'll write down as such x2 minus x1 plus 2f y2 minus y1 equal to 0. Take x2 minus there are x2 minus 1 here and x2 minus x1. So x common, take commonly x1, then you have here x2 plus x1, okay, plus this 2g, right? And similar way, take y2 minus y1, and you have this is y2 plus y1 plus 2f equal to 0. So what we are doing, and we want to have the slope. So how do you get it? Take keep x2 minus x2 this portion here, x2 minus x1, x2 plus x1 plus 2g. this side, bring it to that side. This becomes y2 minus y1 into y2 plus y1 plus 2f. Now what we are doing, bringing this to here and this to here, that becomes x2 plus x1 plus 2g divided by y2 plus y1 plus 2f equal to minus of y2 minus y1 x2 minus x1. So if you see here, this is the slope of two given points. If you have 2 points, you can find out the slope. Now this is the case with the p and q. Now we want to make bringing q to p. That means what? There is a point. The chord become this. This is nothing but the chord PQ becomes tangent at P. The slope of the tangent is so in that process, your what is happening now? The x2 becomes x1. That means what? This equation becomes x2 2x1. So I'll write on first. I want to include one step. X2 it becomes x1 and then x1 plus 2g divided by y1 plus y1 plus 2f equal to minus this is what slope. So this becomes what? 2x1 plus 2g divided by 2y1 plus 2f, that is x1 plus g divided by y1 plus f. So this slope is equal to this one. So we can transfer this. So we'll keep minus here and make it plus here. So that becomes this minus, this minus, this minus. So this is the slope of what? The slope of tangent. Slope of tangent to be found, but what we need is equation of tangent. Equation of tangent. So if we are given two points, we can write line equation as y minus y1 is equal to m into x minus x1. So our m is here, this one is m. The whole portion is m. So what we'll do, we'll substitute here y minus y1 equal to minus x1 plus g divided by y1 plus f into x minus x1. So if you multiply all together, this becomes y minus y1 into y1 plus f equal to minus of x1 plus g into x minus x1. If you multiply, you'll get y into y1 plus yf minus y1 square, actually yf you had to write fy because f is constant, minus y1 square minus fy1 and then equal to minus xx1 minus x1 square minus xx1 minus x1 square plus gx minus gx1. If you come this side, then it becomes xx1 plus yy1 plus gx. So this negative part will come here, gx plus fy minus x1 square plus y1 square plus gx1 plus fy1 equal to 0. Now this is the equation. So stop there, and now we'll come to the general equation. So since x1 y1 is a point on the circle, so we can substitute this point in the general equation, then becomes x1 square y1 square plus 2gx1 plus 2fy1 plus c equal to 0. So if you split this one, this can be split x1 square plus y1 square plus 2, this can be split. There is gx1 plus fy1. Okay, this portion, because we have this portion, this separately, and then we have additional gx1 additional fy1 and then plus c equal to 0. Now if you bring that this portion to right hand side, you will get minus sign. That minus sign I will put here, minus of x1 square plus y1 square plus gx1 plus fy1 equal to gx1 plus fy1 plus c. So I can very well substitute this into this equation. This equation I can call it as 1. This is equation number 1. So I can substitute this value value of this one into that equation. Then what will happen? Your x1 y1 xx1 equation 1 becomes xx1 plus yy1 plus gx plus fy becomes plus gx1 plus fy1 plus c equal to 0. So what's happening? So xx1 plus y1 plus g x plus x1 plus f y plus y1 plus c equal to 0. So this is the equation of normal, the equation of tangent. Equation of tangent. So now to find normal, if you have a tangent, it is very easy to find the normal. How do you find the normal? Just you'll have you know that what is the slope of tangent? This is nothing but minus xc plus 5. So m1 into m2, m1 m2 equal to minus 1. Then m2 equal to, if it has a minus 1, this becomes minus minus plus cancel. So just reverse it. What is y1 plus f? The slope of tangent is minus x, x1 plus g, y1 plus f. So this is a tangent line, and then this is m1. So your m2 will be minus 1 by 2 m1, which is nothing but minus of 1 by minus x1 plus g divided by y1 plus f. This is nothing but y1. So this minus minus cancel. Y1 plus f divided by x1 plus g. With that, you can write the equation. So you'll get again 2-point formula, 2-point line equation. This is what y minus y1 equal to y1 plus f divided by x1 plus g into x minus x1. So multiply together y minus y1 into x1 plus g equal to y1 plus f x minus x1. This gives you x1 times y minus y1 plus g times y minus y1 equal to y1 times x minus x1 plus f times x minus x1. Bringing together, this becomes yx1 minus xy1 plus g times y minus y1 so yx1 minus x1 y1 plus g y minus y1 equal to y1 x x y1 x1 y1 plus f of f into x minus x1. Now you have this one cancel. You'll get yx1 minus xy1 plus g of y minus y1 minus f into x minus x1 equal to 0. This is the equation of normal. Now there is a remark. For the circle equation, x square plus y square is equal to a square, and g, that is h comma k equal to 0 comma 0. That means center is 0 comma 0. No g and f. Then equation, tangent equation becomes xx1 plus yy1. This g, f and will go off, and there is only the center will be a square. A square will remain as such, and you will have xx1 xx1 plus yy1 equal to a square. And for the normal equation, normal also the same. So this equation yx1, this is xy1 yx1 minus xy1 equal to 0. We can also write xy1 minus yx1 equal to 0. This is a special case where your circle is x square plus y square and center is 0 comma 0. What is the condition for y is equal to mx plus c line to be tangent to the x square plus y square is equal to a square? The second one will find the point of contact, the where the tangent forms this line touches to the circle. The first one is condition. What is the condition? We know that the perpendicular distance of a line from a point. The line is the perpendicular distance uh, of the line, that is y is equal to mx plus c from 0 comma 0. Why 0 comma 0? This x square plus y square circle, it represents, this is your a, and this represents your x square plus y square plus equal to a square. So radius, this point is 0. So if this is the line y is equal to mx plus c, uh, so to be frank, this is not a line. This will be a line which will be like this. So this is the point. This will be y is equal to mx plus c. So we want to find out what is the perpendicular distance from this line, from the between the line and this point. So from the straight lines equation, where the perpendicular distance d is equal to for example, in general, suppose you have line ax plus by plus c equal to 0, and you have a point x1 y1, then your distance will be magnitude of ax1 plus by1 plus c divided by root of coefficient of this one plus b square. This is a kind of formula. So using that formula, we'll find the distance. D is equal to what is our line? What is our line? This y is equal to mx plus c becomes y minus mx minus c equal to 0. This is very similar to ax plus by plus c. Then your distance will be a that is ax1. That means 1. What is y1? Okay, let us take y. Y 1 into y. Your x and y. Here x equal to 0, y equal to 0. This is the point, right? So if you substitute that, you'll have modulus y into y is 0, 1 into 0 minus m into 0 minus c modulus divided by what is this one? Root of x coefficient m square and plus 1. So with that, what you'll get it? D is equal to this is it. This becomes 0. This becomes 0, and this will be modulus c modulus of c divided by root of m square plus 1 square. So your this d is nothing but, if you see here, what is this d? What is this one? This is nothing but this one. So this becomes a is equal to a is equal to c divided by root of m square plus 1. If you take this, becomes c is equal to a into root of m square plus 1, and if you are squaring on both sides, c square is equal to a square into m square plus 1. This is the condition for y is equal to mx plus c to be tangent to the circle x square plus y square equal to a square. Okay, the second one, point of contact. What is point of contact? Let here, if you if our where the tangent makes, this is your p point x1 y1. So we want to find x1 y1. How do you find that x1 y1? Uh, so this is a circle with the c 0 comma 0 where radius a. P is the contact point x1 y1, and your tangent y is equal to mx plus c. So if that is the case, so since the p x1 y1 is on the line y is equal to mx plus c, we can write y1 is equal to mx1 plus c. We already know that even the circle with center 0 comma 0, the tangent will be x, equation of tangent to circle with center 0 comma 0, radius a is equal to x1 plus y1 equal to a square. So both these equations represent the same in the sense, for two lines to be parallel, they're what to say, you can have this, you can write y1 equal to minus x1 plus a square. So this is the second equation, this is the first equation. So since two equations represent the same, their coefficients will be equation coefficients 1 and 2 are proportional. That means they maintain same ratio constant. That means if you take y1, y coefficient, x coefficient, and then constant, you will have y coefficient is, if you take this one y1 divided by 1 equal to, and then x minus x1 divided by, what is the x coefficient here? no, don't need to write. This is okay. Now your y coefficient is 1 here. The here y coefficient is y1 by 1, and then x coefficient minus x1 here, x coefficient m equal to, and here it is a square divided by c. So now you have equations. All the three are proportional and they are same. So if you equate y1 divided y1 divided by 1 equal to a square by c, and your the one thing you have to see here. So this is equal to y1 equal to a square by c, and x1 by m minus equal to a square by c, which is nothing but x1 equal to minus m into a square by c. So we know that c is equal to plus or minus from the equation, the y is equal to mx plus to be tangent to the circle. The condition is c square is equal to a square root of 1 plus m square. That means c is equal to plus or minus a sorry, c square is equal to a square into 1 plus m square. If you take square root on both the sides, c is equal to plus or minus a root of 1 plus m square. So for c is equal to a into root of 1 plus m square. This is positive value. This is positive. For this, x1 will be minus m a square divided by a into root of 1 plus m square. So one a will get cancelled, one, and then you will have minus m divided by root of 1 plus ma 1 plus m square, and your y1 equal to y1 is a square divided by a into root of 1 plus m square, which is equal to a divided by 1 time, and then a divided by 1 plus m square. This is a 1 point, and then for the another c value minus a root of 1 plus m square, it will be x1 equal to minus m a square divided by minus a root of 1 plus m square. So the minus minus will get cancelled, and you have 1a. In that case, you'll have your a into m divided by root of 1 plus m square, and your y1 will be a square divided by minus a root of 1 plus m square, which is equal to, again you had to cancel 1. It will be a divided by, that is minus root of 1 plus m square. So you'll have, this tells us so your point of contact will be either a minus, what is x1 minus ma minus am root of 1 plus m square, and then a divided by root of 1 plus m square, or else another point, or else am without minus root of 1 plus m square, and then minus a by root of 1 plus m square. So these are the two contact points. Since y is equal to mx plus c is your tangent to the circle, then your tangent equation will be, the equation of tangent can also be written, can also be written y is equal to mx. Instead of c, you can write root of a into root of 1 plus m square. Now we have a theorem, another theorem. From any point outside the circle, x square plus y square is equal to a square. Two tangents can be drawn. This we need to prove. So for the proof, we'll see uh, P is the point, some external point. We'll take so this is a diagram. So P is an external point x1 y1, and the equation of tangent we already know. The equation of tangent y1 y is equal to mx plus or minus a into root of 1 plus m square. So it passes through the point x1 y1. Okay, this is the tangent line. Y is equal to mx plus c. So y1, if you substitute this point p, substitute point p x1 y1 in the equation. So y1 equal to mx1 plus or minus a into root of 1 plus m square. Say suppose if you take this y1 minus mx1 equal to plus or minus a root of 1 plus m square. The squaring on both sides. So squaring on both sides. So in that case, plus or minus plus either plus value or minus value both will give the plus. So y1 minus mx1 whole square is equal to a square into 1 plus m square, right? So if you bring so expand this one, y1 square m square x1 square minus 2mx1 y1 equal to bring this equal to a square plus a square m square. If you bring that side, this becomes y1 square plus m square x1 square minus 2m x1 y1 minus a square m square equal to 0. This is a quadratic equation in m. If you rewrite m square x1 square, okay, this is a constant. These are the points, right? So minus 2m x1 y1, this becomes y1 square minus a square m square. So if you take m square is common, x1 square minus a square minus 2m x1 y1 plus y1 square minus a square equal to 0. So this is common. Okay, this is of quadratic equation in m. This is m square m, and this is a constant. This is a quadratic equation. That means what? M will have two values. M will have two values, that is two slopes. Means we can draw two tangents from any external point to a circle. Circle x square plus y square is equal to a square. So there is a note, that is, if x1 comma y1 is a point outside the circle, then both the tangents are real. Both the tangents are real. That means we can draw physical two tangents. Suppose this is a condition 1. Then second, if this is inside the circle. The tangents will be, you'll get m value, but the tangents are imaginary. Imaginary tangents we can draw. Suppose it is, the point is on the circle, uh, then the two tangents coincides. No, only one tangent. Okay, this you can find. Earlier we have seen that if you have a point circle somewhere here, so find the distance between this P and O, and you'll have a Q here. This is A. If suppose OP is greater than, so that is a similar case we are finding here. Okay, thank you.